We're going to be talking about how to design experiments and collecting the data, and a couple of the things that we need to look at. First, the amount by which the pieces of data in the set differ is called variability. So when you look at a set of data, it's important to measure variability or look at different types of variability. There are different types of variability, and so you have to pay attention to those when you actually design experiments. And what we mean by different types of variability, there are, first of all, measurement variabilities. Suppose 20 students measure the length of a board. Well, when you think about measurement, are all 20 students going to measure it exactly? Well, they might, but some of them might say that it's exactly 5 feet. Some of them might say that it's 5 feet 1 inch. Some of them might say 4 feet 11.5 inches. So it depends on how accurate they want to measure. And so for measurement variability, a couple of things you have to pay attention to. How much variability or how much difference can you actually expect or is acceptable? I mean, if you think about measuring the length of a board, all of these, if it's around 5 feet, yeah, I would probably accept all of these. But if somebody said those 3 measurements and then somebody else said 5 foot 6 inches, I would kind of wonder. That one might not be very close. So you have to pay attention to, is it drastically different? There is what we call natural variability. Any two individuals are different. Even genetically identical twins differ. They differ in the way they act. They differ in their intelligence. And in all honesty, you can tell there's a slight difference in their looks. So there is a natural variability. Variability between 2 trees, variability between siblings, that type of thing. There is also what is considered experimental variability. Factors are altered to produce changes in a subject of study. What we mean by that is we apply different treatments whenever we're looking at an experiment. And so we apply different treatments that will cause or possibly cause different results. And let's just say we're growing a garden, okay? We may give one flower bed fertilizer, and then another bed we may leave completely alone and do absolutely nothing to it. And then the other flower bed, we don't give fertilizer, but we at least give it water and we weed it and things like that. So we've actually applied different treatments. This one gets fertilizer. This one, we planted it and we've left it alone. Weeds are allowed to grow in it. It gets whatever water the environment gives it, that type of thing. So you have done experiment on what is going to give you the best yield for your flowers or your fruits and vegetables, whatever you've planted. There is also what is considered sampling variability. You're selecting a group of college students to measure their reaction to a question. So let's say that my question is, do you enjoy math? Okay. If I go into, say, just 20 students randomly, then if it's random, I'm probably going to get a fairly good representation or a better representation of the population. As opposed to if I go into a group of students that are English majors and ask 20 of those students, there's going to create quite a bit of what we consider bias. Because most English majors are not going to enjoy math. It's kind of vice versa. Most math majors don't enjoy English. Now, that's not to say that all English majors do not enjoy math, but if I just randomly go across campus and select students and ask if they enjoy math, I might get some yeses, some nos. But if I specifically go into certain classrooms, then I'm going to create some bias. So we have to look at whether or not we are purposefully creating any bias. We want to make sure that we eliminate as much bias as we possibly can. And so in each of these contexts, we have to consider how much variability is actually acceptable. Just like with the experimental variability. Would leaving something completely alone compared to giving something fertilizer and then watering and weeding it be acceptable? I mean, this one doesn't have much of a chance compared to the other two. Also, with the measurement variability, they should all be probably within a reasonable amount. Okay? And so those are different types of variability that we have to pay attention to when we are designing an experiment. And in the next video, we will talk about some other types of definitions and how to continue with designing the experiment.